In the last lecture, we saw how to read data in a numerical format. Like usually the data is read in a structured way, in the form of a tabular data. So to process tabular data, the currently available data structures were not sufficient. And that is the reason two other data types have got evolved over a period of time. Those two data types are called as extended data types, which are made available through these two libraries. Libraries are Numpy and Pandas. So we'll see what Numpy library is for first of all. The Numpy library is for numerical, it's called numerical computing Python, that stands for Numpy. And I'm importing this library as import numpy as np so that I will be able to create numpy arrays by making use of this library files. So when I say numpy arrays, these are called as n-dimensional arrays. So meaning using this I can create either a one-dimensional, two-dimensional or any other multi-dimensional arrays using these methods. So in the first case I have created just a single one-dimensional array with help of this np.array method. So similar to list, there are multiple other methods that is available with numpy package. There are many sorting, you can sort, you can insert, split and do multiple other operations using numpy library. So for the sake of simplicity, I have only taken three simple commands to show what are the potential of numpy library. We can even do mathematical calculations using the same numpy library. So here I have calculated np.mean. Mean is the method that is present inside this library, and I am passing the array as my input parameter. So this is going to calculate the mean, and similarly I can calculate median, standard deviation, etc. There are multiple other methods which we can make use of this using this numpy library. So if I am going to execute it one by one, I will be able to see the result also in the console window. For standard deviation, it comes around 2 point something, 2.581 it comes. So now, similar to NumPy, there is another library called as Pandas. Now Pandas, why Pandas library comes into picture? This is, Pandas include most of the features, whatever already present in NumPy. But the advantage of Pandas is it can do file related processing much more efficiently, and also we can read files directly using Pandas. So when we are able to read files, we can readily create two-dimensional arrays called as data frame. So instead we can call it as Pandas data frame. So a two-dimensional array, or in this case it's a data frame. So there is certain difference between a two-dimensional NumPy array and a data frame. The differences are, in NumPy arrays there are no indexes present. So an index can be considered as any Excel sheet with this kind of column names and row numbers. So these forms the index of the data frame, I would say. In case of NumPy, there are no indices. It is just a plain matrix. But in the case of a data frame, we can name indices both row wise as well as column wise. So that is the speciality of data frame kind of data types. Okay. So to create a new or a fresh data frame with our own values, we can make use of pd.dataframe or pandas.dataframe within brackets. The first argument usually will be a dictionary. So this dictionary, it can be a dictionary or any collection data type. With the supplied information, it automatically creates the data frame as well. So in this case, I am giving a dictionary data type. So how this dictionary data type will be read is, the first key value A will form the column names. So A, B, C will become the column names, and values for this particular list with 4, 5, 6, 7, 8, 9, 10, 11, 12 will become the column values. And for each row, I am also assigning an index value. Assigning an index value is optional. If we do not give this parameter, it will by default start from 0 position. So 0, 1, 2, 3 will be the default index values. and even the key names are optional. So if we do not define this, even the column names would become 0, 1, 2. If I am going to give a key part, then that will be taken as the column name. Okay. So when I create this data frame, it gets created, and I can give print df to see how the value is contained. So this is how the data frame values are contained. ABC forms the column names, and 1, 2, 3 are the indices that we have already given input. Since there are 3 values, we have given 3 index. The number of index values should match the number of column values. So that would combine together form one single row. Okay, and also all the values in each and every column should be same in number. Only then the rows will be equal in quantity. Any row cannot have uneven number of values. Okay, so these are rules while creating the data frame, which we have to remember as well. And the same case as in Numpy, even with Pandas, we can do multiple other editing operations. We can split, combine, and do lots of other operations, and also mathematical operations, even graphical operations can be computed with help of Pandas. So in this case, I am plotting the values of data frame. So this gives a simple plot output. I did not give any values into what my plot data kind can be, what are the inputs it should be, nothing. But we can define all those different kinds of information inside as separate arguments. But by default, there is no need for any arguments. So it constructs a graph automatically. So how it constructs is each column, it plots its values. So 4 is the so the line crossing 4 is the column A, and 7 is column B, and line crossing 10 or nearby 11 is column C. So these are the values. That's how it has read and plotted it. And there is one another function that I have captured here that is called as correlation. When I execute it, this gives the correlation coefficient of each and every row value, each and every column value against the other column value. So in this case, A is compared against itself, A is compared against B, A is compared against C. Similarly, the next column, B is compared against A, B is compared against itself and against C. Likewise for column C also. So correlation is a mathematical term which we will define in the next video lesson. Okay, so until then, just understand there is a correlation, a mathematical function, and which values we will be able to calculate it here. Okay, so there are lots of other further contents to be read, which I will be giving references for both Numpy and Pandas. You can go through it and increase your understanding about these libraries. With this, I am completing this lesson. Thank you. See you in the next video.